Pharmaceutical manufacturing treats ambient air as a strictly controlled raw material, subject to the same rigorous purity specifications as any active chemical ingredient. A single microscopic contaminant entering a sterile drug batch can compromise a patient's immune system and trigger a multi-million-dollar product recall. Simply powering on a facility's air handling unit, the massive industrial HVAC system designed to filter and condition the air, does not guarantee environmental sterility. To pass a regulatory audit, the system's performance must be mathematically and physically proven. A machine behaves entirely differently in a static vacuum than it does on an active manufacturing floor. This requires state-dependent validation. To achieve compliance, engineers systematically prove the theoretical design limits of the space through operational qualification, or OQ, and evaluate its dynamic stability through performance qualification, or PQ. Documenting the specific delta between OQ and PQ provides the physical evidence required to certify an unverified mechanical space as a legally compliant cleanroom. Operational qualification is a severe stress test for the HVAC infrastructure. The mandatory condition is the at-rest state. The empty room allows engineers to evaluate the machine in isolation, verifying it maintains functionality at its absolute operational limits. The first critical metric we test is airflow velocity and volume. Engineers measure the speed of the air directly at the face of the HEPA filters. HEPA stands for high-efficiency particulate air, and these physical filters must deliver a strictly uniform volume of clean air to effectively sweep particles out of the room. The second critical metric is pressure differentials. Following fluid dynamics, air always flows from high pressure to low pressure. By engineering pressure cascades, cleanroom air is forced outward from the cleanest zones through doorways and into successively lower pressure, less clean zones. This creates an invisible physical barrier that blocks contamination from entering the sterile core from adjacent manufacturing areas. If the facility fails to maintain these strict pressure differentials, unfiltered air can flow backward, rendering the entire filtration system useless. Passing these initial airflow and pressure tests confirms the HVAC system has the raw physical power to manipulate the room's atmosphere. The third OQ metric is HEPA filter integrity, or the PAO smoke test. We use polyalpha-olein, a synthetic oil, to generate a uniform challenge aerosol. Engineers inject these dense challenge aerosols directly into the ductwork upstream to hunt for bypasses in the filter media. The tolerance of this test is exact. Even a pinhole leak in the filter framing or the media itself is an instant critical failure. The final OQ metric evaluates alarms and automated safety interlocks. We intentionally induce artificial failures, such as executing a sudden exhaust fan shutdown or triggering a total power loss. Validation engineers then observe whether the system's automated safety protocols accurately detect the fault and report the breach. Completing OQ proves the machine physically operates to its design specifications and safely fails under stress. But it only proves this within a perfect static vacuum. Performance qualification, or PQ, provides the real-world equilibrium test. The mandatory environmental state for PQ is the operational state. By introducing active personnel and heat-generating machinery, engineers intentionally inject entropy into the previously static environment. The testing methodology changes here. Whereas OQ relies on instantaneous limit testing, PQ relies on longitudinal data mapping. The first PQ strategy is extended monitoring. This chart shows the transition from single-point testing to continuous, relentless data logging over an extended time frame. Over several days or weeks, sensors track temperature spikes, humidity fluctuations, and airborne particulate concentrations. Human movement directly spikes particulate generation in the room. This tests the HVAC system's ability to clear the air rapidly and return the suite to baseline cleanliness. PQ extended monitoring evaluates the system's real-time endurance, proving it can actively scrub the environment faster than humans and machines can pollute it. The second PQ strategy involves worst-case scenarios. Engineers intentionally push the operational environment to its maximum planned stress capacity. This includes testing the room's recovery rate when the maximum allowable number of personnel occupy the space simultaneously. It also accounts for the stress of a shift change, where multiple doors are opening and closing in rapid succession, threatening the established pressure cascades. The third PQ strategy addresses seasonal variation. PQ is often split into multi-phase testing to account for external environmental extremes, comparing the atmospheric load of summer humidity against winter dryness. Surviving worst-case scenarios and seasonal extremes proves the HVAC system is intelligent enough to auto-correct against unpredictable environmental entropy. This matrix isolates the functional differences between the two operational phases. OQ focuses strictly on mechanical functionality in an empty room, while PQ focuses on environmental stability in an active space. OQ utilizes short-term physical limit testing, while PQ requires long-term trend analysis. The core regulatory distinction is that OQ verifies the physical design specifications were met, whereas PQ verifies the actual manufacturing process is under control. It is entirely possible for a system to perfectly pass OQ but fail PQ if the human manufacturing process introduces more entropy than the mechanical design can handle. Operational qualification proves the machine can do the job. Performance qualification proves the machine consistently does the job under pressure. Without complete longitudinal data from both protocols, a cleanroom is unvalidated and legally uncompliant. Skipping validation turns a sophisticated manufacturing facility into nothing more than an expensive box with a fan. If you need a deep dive analysis into the specific fluid dynamics and methodology of PAO HEPA filter leak testing for your next audit preparation, let me know in the comments.